Today, lesson 35A, day number 2 of the distributive property, and it's really just an extension of yesterday. Yesterday, I restricted all of the problems to integer values. Today, we're simplifying expressions using the distributive property with rational numbers or rational coefficients. Today, we're going to continue to work on stating distributive property problems correctly, like 3 times the quantity of x minus 2.3. So this should go pretty quick, simply because it's the same thing we did yesterday, except with just decimals and fractions involved. So let's go ahead and get started. Here is what we talked about yesterday, the idea of the distributive property, where we're multiplying the outside number by everything on the inside of the parentheses. So this one, 5 times the quantity of x plus 3 is equivalent to 5x plus 15. 6 times the quantity of y plus 7 is equivalent to 6y plus 42. And 3 times the quantity of m minus 8 is equivalent to 3m minus 24. Here's the first one for today. Everybody go ahead and do number 1. Using the distributive property from yesterday, we're multiplying 3 times the quantity of x minus 2.3. So we end up with 3x minus 6.9. So 3 times the quantity of x minus 2.3 is equivalent to 3x minus 6.9. Everybody now do number 2 and number 3. Compare number 2 and number 3 with your shoulder partner. The 1s take the odds, the 2 take the evens. Go. Lucas, number 2.
Number 2 is 4x plus 3.
Wait. Let's read it correctly, please.
That the expression is 4x plus 3.
Yeah, or you could have said 0.5 times the quantity of 8x plus 6 is equivalent to or equal to 4x plus 3. All right, number 3, what did you get?
I concluded that the expression is negative 7.2x minus 1.68.
Anybody disagree with that? She said negative 7.2x minus 1.68.
7.2x plus 1.4. Negative 7.2x plus 1.8, because if you multiply the 1.2 and 0.4 when they're both negative, it would turn into positive.
Yeah, and I didn't waste any time getting to that point that I was trying to make yesterday, and it's this issue where we have a negative 1.2 times a negative 1.4, which has to be positive, so it should be plus 1.68. And it's usually, at this point, somebody says, well, how do you know that's a negative 1.4? And I've probably already said this 50 times this year. If you're not sure, add the opposite in a subtraction situation, and that will clear it up. That is a negative 1.4, but it should be definitely negative 7.2x plus 1.68. Okay? All right, so then sometimes we have decimal values that we're dealing with. Sometimes we have fractional values. It's no different. Utilize the distributive property, so we would multiply 1/2 times x and then also 1/2 times 8. And we end up with 1/2 x minus 4. Shouldn't be a big issue. Everybody now go ahead and do number 5 and 6 and 7. 5, 6, and 7. Number 5, Charlene.
3 times the quantity of 5x plus 15 is equivalent to 3x plus 9.
All right, very good. And here's the reason why. 3/5 times 5x is 3x, and 3/5 times 15 is 9, and therefore it is equivalent to 3x plus 9. Jessica, number 6.
3/4 times the quantity of 8x plus 2/3 is equal to 6x plus 1/2.
6x plus 1/2. Very good. And here is the reason why. 3/4 times 8x is 6x, and 3/4 times 2/3 is 1/2. All right, and then number 7, and I think this is one where we're going to have to maybe start having the conversation about how to appropriately write expressions. Okay? Drew? How about number 7?
Number 7 included that expression is 5/3 x minus 556.
5/3 x minus 556. That's kind of hard to say, huh? All right, so we use the distributive property. And, okay, so I think right now we're going to make the decision, all right? From this point forward, I want to see expression answers in what we typically refer to as standard form. The constant needs to be at the end, okay? Like it has been in pretty much everyone. And in addition to that, I've been hinting at this. It's now time to start writing expressions with improper fractions instead of mixed numbers. It just looks nicer. It looks a little more sloppy if we write that as 1 2/3 x. So it is at this point that this is the way that I want to see them. We had a question about this yesterday, and somebody kind of had a question about the last quiz where more than a few of you left one as 6/3. Let me kind of write that down. I don't remember what the rest of it was, but there were a few of you who left, I think more than a few of you, who left a problem kind of like this. That wasn't exactly what it was, but it was something like that. What's the problem with that? They heard me say improper, but they didn't catch the whole part of it there.
It should only be improper if it doesn't simplify to an even number.
Yeah, and what's 6/3?
2.
That's 2. So yes, I want to see improper, but I do want to see reduced, and that's the key here, is that this, if that's what you ended up with, it should be 2x minus 1/2. So I think at this point, this is the point where I want to see expression answers written the way that they are supposed to be written. Improper fractions reduced and in standard form. Okay? All right, so then that brings us to really the next to last idea for today. Then this is just an extension of what we did yesterday. Sometimes we have to use the distributive property a couple of times and then combine like terms. So I'm going to let you go ahead and try number 8. I mean, it's really just what we did yesterday, but we have fractional values in there. So number 8, we use the distributive property twice. 3/5 times 5x is 3x. 3/5 times 15 is 9. And we don't always just end up with integers there. It just happens to work out that way in this one. 2/3 times 6x is 4x. And 2/3 times 3 is 2, or subtracting 2 there. And so now we have to combine our like terms. We have a 3x and a 4x, which is 7x, and a positive 9 and a negative 2, which simplifies to positive 7. All right, can I get all of you to do number 9, please? So number 9, very similar to number 8. We have to use the distributive property twice. 1/3 times 9x is 3x. If you can't do that math in your head, then just do the work off to the side. 1/3 times 12 is 4. 3/4 times 4x is 3x. And 3/4 times 8 is 6. And so we piece all that together. We end up with 3x minus 4 plus 3x minus 6. Combine like terms, so combine the x's together, combine the negative 4 and the negative 6, so the constants together, and we end up with 6x minus 10. So then that leads us to our last idea for today, and that is an idea that we've talked about several times, and that is, well, what happens if you have a mixture of fractions and decimals? And I want to make clear, I've never said you must convert problems like these all to fractions. I've never said that. What I have said is that for many people it's easier to do that because of the idea that if you converted a problem like this to all decimals, you would have some repeating decimals in there, and some students have problems with adding terminating decimals with repeating decimals. It can be done. It's just that I have found from experience more students have problems with that than they would if they had converted that same problem to fractions, because then you're just finding common denominators and doing all of that stuff. But you know, we've seen this problem before. 1/5 f or 1/15 f minus 7/15 is equivalent to 0.06 repeating f plus 0.46 repeating. All right, so that's what the last two problems are all about. You make the choice on which direction you want to go. because we'll talk about both decimal values and fractional values. Go ahead and try number 10. So number 10, I'm going to convert the 0.9 to 9/10. And go ahead and multiply it out like that. So I just sort of replaced it with 9/10 in my head and multiplied out. And now I end up with this. And from there I need to convert the 6x to 60/10 so I have common denominator there. And the 48/5 to 96/10 to have a common denominator with the negative 27/10. And now I have like terms right here. That is 114/10 x, but that is 57. I don't know why I wrote 110 tenths. So that would be 57/5 x, and then we have 96/10 and negative 27/10, and that is 69/10, which of course cannot be reduced. And so this is one way of writing it. So this, I believe, is the very first problem where we've had that issue where I'm now saying this is the way that I want it written unless you convert it to decimals. So could somebody please give me the equivalent value to that with decimals? Because I know a few of you did it. Yeah.
11.4x plus 6.9.
11.4x plus what?
6.9.
Very good. Either one of these are okay. They are equivalent to each other. They represent the same values, okay? So either 57/5 x plus 69/10 or 11.4x plus 6.9. And so we will end today with number 11. Everybody do number 11, and then we'll compare with our shoulder partner. So you have to make a decision, either convert all of the fractional values to decimals or convert all of the decimals to fractions or mixed numbers. That's entirely up to you. As long as you do your math correctly, you should get something that is equivalent to the other thing. I'm going to convert. I'm going to stay consistent here and convert to mixed numbers. So we have 4 times 3/2 x minus 4 times 3/5 plus 8/5 times 2x plus 8/5 times 5. And then when I simplify all that, I end up with 6x minus 12/5 plus 16/5 x plus 8. Combine like terms. And to do that, I have to find common denominators. So I did that right there. And so right here, I have my common x's. So that would give me 46/5 x. And then I have my constants that I can combine together. Negative 12/5 plus 40/5, that is plus 28/5. So if you did things as fractions or mixed numbers, that's what you should have. Could somebody give me the equivalent value as a decimal? Nobody did that one as a decimal? Yes.
9.2x plus 5.6.
Plus what?
5.6.
5.6. Those are equivalent to each other. They're both okay. All right. We are finished for today.